Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 1 for this week. And we've got a tropical storm perhaps on the verge of becoming a hurricane out of the Atlantic, and you might be asking yourself, what's going on here? Well, technically the hurricane season goes all the way till November 30th. Having a hurricane or a tropical storm in November is not unprecedented by any stretch. And one of the reasons that it can occur this late in the season is that the water temperatures, the maximum water temperatures, tend to lag the warmest air temperatures that occur over land masses. And we're going to talk a little bit about that today. It relates to something called specific heat, heat capacity, and again, why the warmest ocean temperatures tend to occur later in the season than the warmest air temperatures. So let's go on ahead here and take a look at some definitions. First of all, the definition of the specific heat is the amount of heat required to raise the temperature of 1 gram of any substance, whatever substance you're talking about, water, air, whatever, 1 degree Celsius, which is about 1.8 degrees Fahrenheit, okay? So, again, it's the amount of heat required to raise the temperature of 1 gram of any substance, 1 degree Celsius. Now, the specific heat of air, and don't worry about the units here, these are simply scientific units, is 1.005 joules per gram per degree C. The specific heat of water is more than 4 times that, 4.186 joules per gram per degree C, which means that it requires 4 times as much heat to raise the temperature of water 1 degree C as opposed to raising the temperature of the air 1 degree C. So when the sun first starts getting strong in the spring months, the air is saying, woohoo, woohoo, oh boy, I'm going to react, I'm going to warm up quick. And the water's saying, it's going to take a lot more effort than that to get me to respond to you, okay? And so as a result, the water heats up slower than the air does, but then by the same token, when you get into the fall, it cools down slower than the air temperature does. So let's take a look at a graph, and what I did was I took a look at the average water temperatures at Wrightsville Beach, North Carolina, for the beginning, the middle, and the end of each month, and then did the same thing for the air temperature at the RDU airport, and the Wrightsville Beach water temperature in brown and the RDU air temperature in blue. Well, the one thing you'll notice right off the bat is that the water temperature never gets as cold as the average mean temperature, the average between the high and the low at RDU, and the water temperature average also gets higher than the average air temperature at any given point in the year. But the thing I really wanted to point out here relates to when these bottom out and when these peak. Now, the air temperature tends to, on average, you look at a 30-year average, tends to occur about the middle of January, and then we start a very slow incline, and then that incline accelerates as we head into February, March, and April, and May. Okay, and we all know that's the case. Now, the water temperature continues to descend and doesn't bottom out until the early to middle part of February, and then it starts its ascent, okay? So again, the water, if it could talk, would be saying, wait a minute, you know, it's easy for you to get the air to respond to this amount of heat, but you're going to have to work a lot harder to get me to respond, okay? And so finally, there is enough heat by mid to late February that the water temperature starts to go up. Then when the sun, starts to really do its thing in the summer months, the average air temperature peak is about the middle of July, which is about right in here, okay? But again, the water is saying, wait a minute, I'm still making use of the heat that I've got already, and even though that amount may be decreasing a little bit as we head into later July and August, it's still enough for me to keep going up. And so the air temperature starts to go down, but look at the water temperature. Look at the separation here as we head into the fall months, how much warmer the water temperature is than the air temperature. And so even though the land masses are getting cool, the water temperature is still up there. And I'll tell you, in some of these areas, the deep tropics like the Caribbean Sea, I mean, the water temperature is still way up into the 80s. And even over where Nicole is right now, the water temperatures are about 28, 29 degrees C, which translates to about 82 to 84 degrees Fahrenheit. That's still plenty warm, enough to get a tropical system going. So this whole idea of heat capacity being so much different from water than it is for air is what allows these tropical systems to continue to develop even into the month of November. And heck, there was a year several years ago where it kept going into December. In fact, we had to go into the Greek alphabet, if you remember that, because there were so many storms that year, and they just kept going and going and going. And this is one of the reasons for that. In fact, probably the primary reason. Okay, Hope that made a little bit of sense. That is bonus weather video for today. We'll have another one for you coming up Friday, and we'll be doing text updates on Nicole, text and images over the course of the next 24 hours as things change. And then, of course, we'll have our complete daily video update coming up late tomorrow afternoon or early evening, as we customarily do. So that is it for today. Hope you enjoyed this. Hope you found it educational. And again, we'll be back with you tomorrow, and we'll have updates in between now and then using text and images. Hope you enjoy. Take care.